Okay, question 13. Two identical shapes are used to form a logo. Each shape is part of a circle. The circles have centres C1 and C2. The radius of each circle is 14 centimetres. The logo has a half-turn symmetry about the midpoint of AB. In other words, if you can rotate it around there. AB is 48 centimetres long, so we've got quite a lot of information in there. So it might be worth starting to write things down. So AB, 48 centimetres long. So let's just write that in first. Okay, so A to B is 48 centimetres. We're also told that the radius of each circle is 14 centimetres. So from the centre to the outside is 14 centimetres. So let's just pop that in as well. Okay, so we've got radius, so centre to outside is 14. Now by now alarm bells should be ringing for what kind of question this is. You're looking at a Pythagoras. So you are looking to draw a right angle triangle, and you've been given more than enough information there in order to find the height of the logo. So we want the total height of the logo, so from here to here, plus that wee bit there, twice, because you get two of them, that's your total height. Stop the video, go and have a wee think. Okay, so what we're looking to do is get a right angle triangle, and using Pythagoras, find a missing side. So what information have we got? So this is my triangle. I've redrawn it up here so it's a wee bit clearer. So this bit here is 14. Let's put that in. So we've got 14 there. There's my right angle. Right angle's there. Okay, so the next bit, we're told we know what this length is here. So I just want this wee bitty here. So the whole thing's 48. This is your halfway mark. So that's going to be half of 48, which is 24. And then we're going to half that again, because this is cutting this in half here. So this bit here is 12. So we'll shove that in. So I now have two sides of a right angle triangle. I've got a 14 and I've got a 12. So I've got enough information to find this side here using Pythagoras. So Pythagoras says that the longest side squared, this one here, is equal to the sum of the two shorter sides squared. So that squared plus that squared. I'm trying to find a short side, so I'm going to take away. So x squared, my short side that I don't know, is equal to 14 squared, take away 12 squared, which is equal to, so that's equal to 52. But that's x squared. I don't want x squared, I want x. I need to take the square root of this beastie. Okay, so the square root of 52 is 7.211 ... So we'll just round that to 7.2 for easiest sake. We're not told what to round to, so 1 decimal place, 2 decimal places, happy days. Okay, so the 7.2 is this wee blue bit here. I want the total height of this logo, which means from there to there, so centre to outside, that's a radius as well. So you get 14 plus this blue bit here, and then you've got the same again there. So that bit is the same as that. So if we do 14 plus 7.2, multiply that answer by 2, we are going to get the total height of this logo. Okay, so our final height is the 14 plus the 7.2, that's that bit there. And then you've got to multiply it by 2 because we've got two of them. So 14 plus 7.2 is 21.2. Double that, 42.4. So the height, entire height of the logo is 42.4 centimetres. Done. Right, marking scheme. If you start out something like this, you are marshalling your facts, you are showing that you're going to use Pythagoras, you're going to get a mark there. Second one, proper use of your Pythagoras statement. Third mark, getting your 7.2, and your fourth mark, getting the total height of the logo. Done and dusted. Right, number 14, the diagram below shows part of a circle, centre O. The radius of the circle is 6.4 centimetres. Major arc, that's a big one. That's this beastie here, major arc. Has a length of 31.5 centimetres. Calculate the size of the reflex angle, this one here, AOB. AOB, so it's this bit here, reflex angle more than 180 degrees. So what we're looking at here is arc length. We're going to be using that and working it backwards. So go and have a think about arc length, how you work it out, missing bits, stop the video and have a shot yourself. Okay, so what you're going to remember is the arc length is equal to the angle over 360 times pi d. Now we've got the arc length, we know or we can work out what the diameter is. It's this beastie here we don't know, the angle. So what we're going to do is we are going to rearrange this so we've got the angle by itself. So the first thing we're going to do is we're going to times by 360. So that now gives us 360 times the arc length is equal to the angle times pi d. I want the angle by itself, so I'm going to divide everything through by pi d. Okay, so 360 times the arc length divided by pi d gets me my angle. So now what I need to do is stick in all my numbers. So it's pi d I need, it's the diameter. I've been given the radius. So to get your radius from your diameter, you double this. So my diameter is going to be 12.8. So chucking all this into the calculator, I get 282.002 degrees. So let's round that to something sensible. So I'm going to round it to 282 degrees. So we get the 282. Even if I rounded it to 2 decimal places, because I've got my zeros there, it's just 282. So that is how you get your 3 marks. So, first mark, we get for expression of arc length. So, writing out this bit here. So, okay. So, getting our 12.8. And then as we start to rearrange it, know how to find the angle. So you're rearranging it so the angle's by itself. And then finally, for getting your 282. So that's 3 marks altogether there. Okay, number 15. A wind turbine has 3 blades as shown. The height, h metres, of the tip of blade A, there's blade A, above the ground in each rotation is given by the height is equal to 40 plus 23 times the cosine of x, where x is between 0 and 360. X is the angle of the blade has turned in a clockwise direction from its vertical. Calculate the height of the tip of blade A after it is turned through an angle of 60 degrees. That is A. So, switch it off, go and have a think and see what you can do. Right, so this x here refers to our angle. So what we're doing is we want to work out the height when our blade there has gone an angle, has rotated by 60 degrees. So we want to know its new height. In order to do that, we take the angle that it's turned by, which is 60, and we substitute it into this formula here. Okay, so subbing that in, the height of the blade is going to be equal to 40 plus 23 cos 60. So you chuck that into your calculator, to get your actual height. So putting that into your calculator, you get 51.5 metres. So that's your 1 mark there. Okay, part B, find the minimum height of the tip of the blade above the ground. So what's the lowest that it actually gets to? So let's think about this. Where's it going to reach its lowest point? If this is tootling round here, it's going to get to its lowest point when it's down there. So what angle has it gone through? Straight line. It's going to hit its lowest point when it's gone through an angle of 180 degrees. Okay, so we know our angle is 180. So again, we're just going to substitute the 180 for x. Okay, so chucking that into your calculator, your height is 40 plus 23 times the cosine of 180 degrees, which gets you 17 metres. So the lowest the tip of that blade is going to get is 17 metres. 1 mark for that. Okay, part C, our biggie. 4 marks for this one. Calculate the values of x, so you're calculating the angles for which the tip of the blade A is 61 metres above the ground. Now, when it's going round, there's going to be 2 points where your blade is 61 metres above the ground. Okay? So, round about there, when it gets to there, and then on its return journey, it's going to be at 61 metres. So we know h. We're told what h has got to be. H has got to be 61. So let's write that in. Okay, so 61 is equal to 40 plus 23 cos x degrees. We need to solve this equation. We want to get cos x by itself. So stop the video, go and have a think and have a go. Okay, so I'm going to rearrange this so I've got cos x by itself. So first thing I'm going to do is I'm going to take away this 40. Okay, that gets me to, so 61 take away 40 is 21. So 21 is equal to 23 times the cosine of x. I want cos x by itself. I need to divide by 23. Okay, so 21 over 23 is equal to the cosine of x. I don't want the cosine of x. I want an actual angle, so I need to use the inverse here. Okay, so putting that in the calculator gets me an angle at 24.070 degrees. But remember, that's just that bit there. We've got another one over here. So we need to use our cast diagram to see what quadrant and how we're going to be doing it. Okay, look at the cast diagram. Now my cosine is positive. So cosine is positive here. We found that one. And it's also positive in the fourth quadrant. So in order to find this angle here, we take our angle in the first quadrant and we take it away from 360. Okay, so 360 take away 24.0 blah blah gets us 335.929. So round the two angles to something sensible, 1 or 2 decimal places. I tend to opt for the 2 decimal places. So rounding both of them to 2 decimal places, the two angles where it hits a height of 61 metres are 24.07 degrees and 335.93 degrees. Okay, that was a lot of work, but it is 4 marks worth. Right, where do my marks come in? So, first one, you get your first mark for this here, for actually substituting in. You get your second mark for getting the cosine of x is 21 over 23. You get your third mark for your 24.070 and your third mark for here, and for rounding, just round them sensibly. So that's your 4 marks there.